Hi everyone. In this video we're going to talk about how to take the derivative of logarithms. But before we jump into derivatives, let's just review our log properties. Let's recall that logarithms and exponential functions are inverse functions, right? So right now let's just remember it for natural log. Yeah? Recall that the natural log of e to the x is equal to x. And this is for all x in the domain of e to the x, so that's for all x, right? And let's also recall that e to the natural log of x is equal to x for all values of x that are in the domain of the natural log of x. And what's the domain of the natural log of x? Those are values of x that are strictly larger than 0. And so these are our inverse function properties of the natural log, as well as how they behave with the exponential function e to the x. So let's also recall that the natural log of a plus the natural log of b is equal to the natural log of a times b. We know that the natural log of a minus the natural log of b is equal to the natural log of a divided by b. The natural log of a to the power b is equal to b times the natural log of a. And the last property is called the change of base property, which we will use. And that says that, before I state the change of base property, all of these properties hold for any base. And remember that the natural log of x is really log base e of x, yeah? But these properties are certainly true for any other base that you want to choose. And if we want to change bases, we have that log base b of a is equal to log base c of a divided by log base c of b. Yeah? And this is how we're going to change base. So I hope that you remember these properties. We'll see these recurring throughout the video today. All right, so let's jump right into derivatives. I know what you're thinking. Boy, gee, howdy. Suppose we have our favorite function y equals the natural log of x. And with this choice of y, we want to find dy dx. And you say, well, I have no idea what the derivative of y with respect to x is if y is equal to the natural log of x. So let's use our inverse function properties. If y is equal to the natural log of x, because the inverse function of the natural logarithm is e to the x, this means that e to the power y is equal to x, right? And with this choice, let us now find dy dx. How do you think we're going to do that? We're going to use implicit differentiation, right? We're going to differentiate both sides with respect to x. And what's the derivative of the left-hand side? Well, the derivative of e to the stuff is e to the stuff times the derivative of what's inside times dy dx. And the derivative of x with respect to x is just 1. And with this, we can now solve for dy dx, as we have lots of good practice doing in our implicit differentiation homework. So now we have that dy dx is equal to 1 divided by e to the y. And we could do better. We can get rid of the y's. What's y equal to? Y is the natural log of x. So that goes there. That's 1 divided by e to the natural log of x. And what is e to the natural log of x? That's 1 over x. And that's kind of cool. What's important here is that we have a domain restriction. The natural log of x is only valid for x's strictly larger than 0. Yeah, so just keep in mind that we do have a domain restriction. And once again, just like we saw with the inverse trigonometric functions, with these logarithms, the derivatives get rid of anything that looks like a logarithm or an exponential function. We get just a nice rational function. That's a weird feature here. So the derivatives of inverse trig functions, the derivatives of these logarithm functions, only result in nice rational type functions, and that's kind of a cool feature. All right, so let's do an example. What's the derivative with respect to x of the natural log of 3x squared? Pause the video. Try to figure this out yourself. Alright, so first, I know what you're thinking. We need to take the derivative of the natural log of stuff, right? What's the derivative of natural log of stuff? Well, the derivative of the natural log of x is 1 over x. So the derivative of natural log of stuff is 1 divided by my stuff, isn't it? And then, of course, we have to use chain rule, so we need to multiply by the derivative of what's inside. And what's the derivative of 3x squared? That's 6 times x. And let's simplify this. This is equal to 2 divided by x, right? But suppose you don't want to do it this way. What if we were to instead use log properties first and then differentiate? And we'll see later on that this is going to be really, really helpful for us. Suppose instead, before we take a derivative, we use log properties to break this up. So pause the video, see if you can use your log properties to break this up into nice simple terms. So first I see the product inside of the natural log, right? I see that this is going to be the natural log of 3 plus the natural log of x squared. But I can use the log property again to bring this power down, right? This is natural log of a to the b, so the 2 comes in front. And really I want to compute the derivative with respect to x of the natural log of 3 plus 2 times the natural log of x. And this is super easy now. What's the derivative of the natural log of 3? It's 0, right? Because natural log of 3 is a constant. And what's the derivative of 2 natural log of x? That's just 2 divided by x. So using log properties allows us to get just the derivatives of nice simple functions, and there's no chain rule that's needed in this case, yeah? So it's going to be super nice for us. Let's do another example that's similar to that. Let's take the derivative with respect to x of the function natural log of x times the sine of x divided by x squared plus 1. Yeah? Before you jump in, just stare at it for a few seconds. If you were to take the derivative of the function as it looks right now, we would have to take the derivative of the natural log of stuff. But then whenever we do chain rule, we'll have to do a quotient rule. And inside of that quotient rule, we will have to do the product rule. I hope that you see that. So the derivative is going to be really, really not pleasant. Yeah? So try to pause the video. Use your log properties to break this down and make it a nice, easier problem. So let's do it together. We have that this is the derivative with respect to x. I see first and foremost a quotient. So it's going to be the natural log of the stuff up top. And you don't have to show all this work if you're comfortable doing this in one step. Yeah. This term here, I don't think can be simplified very nicely, but this term can because I have a product. Yeah. And what's the natural log of the product? It's the sum of the natural logs. So it's really the derivative with respect to x of natural log of x plus the natural log of sine of x minus the natural log of x squared plus 1. And these are a lot easier now. There's no quotient rule anymore. There's no product rule for us, just a little bit of chain rule, and that's okay. So let's take the derivative now. Pause the video if you're not 100% sure how to do this yourself. Try to figure it out. Alright, so the derivative of the natural log of x is of course 1 over x. What's the derivative of the natural log of stuff? It's 1 over stuff, right? And now we need to multiply by the derivative of what's inside. My inside function here is sine of x, and what's the derivative of sine of x? That's cosine of x. Minus, what's the derivative of natural log of stuff? It's 1 over stuff. Times the derivative of what's inside, which is 2x. And we could rewrite this just a little bit. This is 1 over x plus, what's cosine x divided by the sine of x? That's cotangent of x. That's kind of nice. Minus 2x divided by x squared plus 1. Cool. Let's do that again. get some good practice with our log properties. Let's take the derivative with respect to x of x squared times e to the negative x. Oops, natural log of that. Sorry about that. Derivative with respect to x of the natural log of x squared e to the negative x. Pause the video, use your log properties to break it up, and then take the derivative. Alright, so if we use our log properties, this is the derivative with respect to x of, I see the product, so the natural log of x squared is of course 2 natural log x plus the natural log of e to the negative x. Yeah? And this is the natural log of x squared here, plus the natural log of e to the negative x. But what's the natural log of e to the negative x? It simplifies even better, doesn't it? This is the derivative with respect to x of 2 times the natural log of x plus negative x. And that's super nice. Yeah? Whenever we take the derivative now, what's the derivative of 2 times the natural log of x? That's 2 over x, right? The derivative of negative x is just minus 1. And that's super nice. Easy peasy, right? Cool. But I know what you're thinking. How do we take derivatives of log base b, where b is some other base, right? So let's consider that. How do we take the derivative with respect to x of log base b of x, where b is some number that's bigger than 0, right? Log base 2, log base 10, whatever you like. To do this, we really want to use our understanding of how to take derivatives with natural logs. How can we use this? Let's use the change of base formula. I know that this is going to be the derivative with respect to x of the natural log of x divided by the natural log of b, right? How could we take the derivative of this? Remember that the natural log of b is a fixed constant that's positive, so this is just a constant. So let's rewrite it just to make sure that we see how to take the derivative here. So the derivative with respect to x of 1 over the natural log of b times the natural log of x. So what's the derivative of a nice easy constant times the natural log of x? It's your nice easy constant times 1 over x. That's kind of nice. Most people don't write it this way though. They write it as 1 over x times the natural log of b. Yeah. Cool. Let's do an example. Let's take the derivative with respect to x of your favorite function, 2 to the log base 3 of x. Yeah? Pause the video, see if you can figure out how to do this yourself. So we could use exponential and log properties here to break this up and make it look super nice, but let's just roll up our sleeves and take some derivatives, right? What's the derivative of 2 to the stuff? It's 2 to the stuff times the natural log of 2, right? And now we need to use the chain rule and multiply by the derivative of what's inside. And what's the derivative of log base 3 of x? It's 1 divided by x times the natural log of 3. Yeah. Alright guys, I hope that this helps. This is all that I needed to say about the derivatives of logarithms. You're going to have lots of good practice in the homework. Feel free to reach out via email with any questions that you have. I'm also happy to set up a time to meet with you in Zoom. And I look forward to seeing you in the next video. Thanks so much for watching.